Hello everyone and welcome to a Jalview training video. I'm Khadija and today we will be exploring the 3D beacons network within Jalview and how we can use this to discover 3D structures for protein sequences in our alignments. Let's get started. The 3D beacons network is a standardized platform that combines data about protein structures, whether they are experimental or predicted models. You can think of it like a one-stop shop that features data from many providers, including AlphaFold, Swiss Model, Protein Ensemble Database, the Protein Data Bank Europe, the Small Angle Scattering Biological Data Bank, and Genome 3D, amongst others. It also includes metadata about how reliable these estimates of protein structure are. It is now possible to access the vast wealth of information this network holds from within Jalview to discover 3D structures for our alignments. Let's see how that can be done. And the star of today's show is the endothelial pass domain-containing protein 1, or the EPAS1 protein. This cellular protein is found in mammalian species and regulates blood oxygen levels. It is quite handy in low oxygen conditions, such as if you were thinking of running for the next Olympics or staking your claim on Mount Everest. Here, we have sequences of the protein that are already aligned and available to us as a FASTA file. We will drag this alignment into Jalview like this. As you can see here, this is an alignment of EPAS1 proteins, isolated from the human, mouse, and rat species. Now I'm going to select all the sequences and then right-click on any sequence ID to then select the 3D structure data option. In this first search, Jalview will extract accession-like words from the sequence IDs to search Protein Data Bank Europe. And once this search is completed, the best structures will be automatically highlighted by Jalview in gray, as you can see here. These have been determined using a combination of the quality of the experimental method and the resolution of the structure. So we have a list here of all the experimental models from Protein Data Bank Europe for our 3 sequences. Now, in this next step of the search process, we can query 3D beacons for additional data like predicted models, for example. Once Jalview has finished communicating with UniProt, you'll notice the dbref search completed indicated down here. In this Structure Chooser dialog box, we can see that some structures cover the entire length of the EPAS1 proteins, whilst others cover it partially or in fragments. If we scroll over to the right, we'll see that for predicted models, Jalview shows confidence scores here. These are either the predicted local distance difference test scores for models from AlphaFold, ranging from 0 to 100, or the Q-mean discal scores for Swiss Model, which range from 0 to 1. And it's important to bear in mind that they're not comparable. Okay, so that's the Found Structures Summary tab for you. We can pick which parameters we'd like to see displayed here by customizing the display options from this tab. And there's many to choose from. Now, Jalview also gives us the ability to filter the discovered structures we've got here using this drop-down menu. Best 3D beacons coverage will identify structures that offer the highest quality for every position in each sequence, whereas multiple 3D beacons coverage will ensure that the maximum number of residues in each sequence are covered using as many different structures as possible. We can also select the best quality structures for each sequence from data specific to any of these sources listed here that are part of the 3D beacons network. Now, for experimental models from the Protein Data Bank Europe, these can be filtered according to the quality and resolution of the structure, as well as the number of protein chains, ligand attachments, and polymer residues. Let's try one filter like resolution, for example, and you'll now notice, as soon as I clicked on it, a button appeared here on the right side. This button will invert the selection according to the PDB filter we've just applied, so we can now see which models fare worse than others. How cool is that? If we right-click and select this option here, this will cause the web page of the protein structure to open in our browser, where we can now scroll through additional information about it, hosted by the 3D Beacon provider. Now that we've checked this out, we can go back and view the selected structures using the 3D viewer currently configured into our Jalview environment. So that's going to be these 3 AlphaFold models here. I'm going to first color our alignment so things are easier to visualize. Let's use the gecko's flower color scheme today. Okay, we have the option for superposition of structures enabled. And now it's time for a bit of Jalview magic. And there we have it, overlapping 3D structures of the EPAS1 proteins. We've got some high-definition structure here, and then you'll notice some spaghetti-like bits here, which are regions with low prediction accuracy. It's important to know how good your structural models are, and that is something we will explore in another training video. That's it for today. If you'd like to brush up your Jalview skills, you can check out our list of hands-on exercises on the Jalview website, specially curated for yourselves. And if you have any questions or would simply like to get in touch with us, head over to the Jalview discussion forum. I hope you enjoyed this video. For more Jalview training content, please subscribe to our YouTube channel. Until next time.